Hi, this is Kevin Trainer, and I'd like to welcome you to my tutorial demo for the classes Counter and CounterClient. We're doing these for the Java course, and this corresponds with part one of chapter 8 in the Reggie's and Step book. And we're going to create, this is the first time that we are creating a custom class, a class of our own to our own specifications. And it typically works out well to build something that's really pretty simple, pretty easily understood. And so we're going to build a counter. Now this is not a programming oriented counter. This is a kind of counter. This will date me, but I remember when I was in high school, um, we had a high school dance, and it was always in the gym every Saturday night, and it there was uh, there was a limit of the number of people you could have in the gym. We do this for basketball games too, I guess, and is part of the fire code. So we had these little counters that well, they looked they're made out of chrome, and they had little counter wheels, and there was a plunger that you pushed, and every time you pushed it, you could uh, you could add one. Okay. Um, and there wasn't any button to subtract one. These were really pretty simple things. And the idea was that you would keep your eye on it, and if there was a limit of, let's say, 500 people who could be in the gym, when you got to 500, you had to stop letting people in. Okay. And so that's what we would do when we ran this thing. So it's that kind of counter that we're talking about, except that I would like ours to be a little more sophisticated. Of course, when we create a new counter, I would like to have it have a value of 0. Okay. So they'll always be kind of reset to 0. And when we're going to have an increment uh, method that's going to increase the value by 1. And I want to make it a little more complicated, so I'm going to have a decrement that will subtract 1. Okay? And in terms of the other requirements, we're going to have a no argument constructor. We are going to have an equals and hash code, and we're going to have a toString. Okay? And how we're going to go about this? Well, we're going to follow the recipe that I've published in my course for uh, creating a new object-oriented class. And the types in Java are either the primitive types, which we've been working on so far, or they're a type that's defined by the name of a class. The only ones we've used so far are the types that come with Java, the classes that are part of the Java distribution. Things like string and random. Okay. Well, now we're going to create a new one called counter. The other thing we're going to create when we're about partway through is we're going to create a client class. Now, client code is code that we use to call code in our classes. Okay. And it becomes a client because it's a user of the primary code. And so a simple testing class is really the simplest client code that we can have. So the class itself is going to be called Counter, and the testing class is going to be called CounterClient. Okay? So here's the recipe, the first couple of items. First, we're going to create the shell of the class using Eclipse, and we're going to remember that we're not going to ask for a main. Then we're going to add the instance variables at the top of our code. We're only going to have one because we just have to keep track of the value. Okay? And we should remember that instance variables should be private. So let's shrink this, and I already have Eclipse open to Chapter 8 Part 1 demo. And the first thing I'm going to do is I'm going to create a package. So in a proper development environment, all your classes, it should be allocated to some package or other. And this is really the first of the chapters where we're going to be doing that. And the conventions for forming a package name are typically that we begin with a domain name and we reverse it. So my domain name of my little consulting and training company is ligent.net. So we're going to start out net.ligent, L-I-G-E-N-T, my little company, and then we're going to say students, and then we're just going to call this a package counter. Typically we'd have a package that would hold more than just a class and its test code, but here we're going to start small, so counter. Okay, all right, and in there we're going to create, the first thing is we're going to create a new object-oriented class called counter with a capital C. Okay, we're going to allow the modifier to be public. That'll be just fine. Do we need to click the box for a public static void main? No, we don't, because object-oriented classes don't have a main. Okay, and we're going to see that we don't call a method, we don't call a main in the object-oriented class in order to test it. What we do is we have another class that we use to test each of our object-oriented classes. So because of that, we're not going to need a main. And the last one down here, inherited abstract methods. In our case, it's not going to do anything, so we're just going to leave it there. So click Finish. And as you can see, we have a class called Counter. And you can also see we have the statement that says what package it's in. Okay, very good. So that's in net.ligent.students.counter, just where we'd like it to be. So let's just take a peek again, look at the first couple of things that we did. We've already done the first part of the recipe. Now we're going to go to the second. We're going to add instance variables to the top of our code, just below the class header. That's inside the class, but outside of any method. And they should include the modifier private. Okay, let's go do that. So inside the class, outside the method. And now what I usually do, or have my students do in the very beginning, is to create a single line comment that kind of announces each code grouping that we add. So the first thing we're going to add are instance variables. Okay. And we're always going to use a private modifier. So private, it's an int, and we're going to call it value. Okay, do we need to give it an initial value? Well, it turns out that there is a default treatment for all instance variables, and they are provided they're primitives, they are set to either well, they're set to 0. So if it's an int, it's going to be set to 0. If it were a Boolean, it would be set to false. So we don't have to initialize instance variables. Why are they called instance variables? Well, because we have one of these for every instance of counter that we create. So this keeps track of the value of this counter. All right, that one's done. Let's take a peek back at our recipe. Well, that wasn't what I wanted to do. Okay. We're up to number 3. If there are any fields such as constants that need to be visible to all instances of a class, add them now. Well, we're not going to have any. Okay, we haven't covered that yet. We're going to cover that in a future lesson. So we're going to skip 3, go on to 4. Add getters and setters for each instance variable. Use the Eclipse wizard to do this. Sounds good to me. Let's look. All right. So we can right-click anywhere in the editor, go to Source, and then the wizard is called Generate Getters and Setters. Okay. Now, it's possible to simply click, check the box for value, okay? And then if we were to go down and say, okay, we would get a getter and a setter generated for the instance variable value. But it turns out that we want the visibility of these two methods to be different. Okay? Why? Well, we want the setter to be public because we'd like any code to be able to control the value, to be able to get the value. Okay? But we want the getter to be private because we want, we don't, I'm sorry, we want it the other way around. We want the getter to be public because we want anybody to be able to get the value. I don't know if I hit it backwards or not, but let's not take the risk. So anybody can get the value by calling the method getValue. And we don't want anybody to be, we don't want anybody outside of this class to be able to set the value because that's going to be something that we do within the class. Okay? So, how do we do that? Well, we've got these modifiers down here, okay? So first, let's create a setter. Let's not check the top box. Let's click the little triangle arrow to look at the two things we can generate, okay? Let's generate a set value and come down and say we want it to be private, okay? We've got that. Okay, and it's added a private set value. Very good. And let's come back and go to Source, Generate Getters and Setters again, and let's again click the triangle and say now we want to generate get value. We want that to be public. Okay? All right. So that looks good. The only thing we need to add now is I would like a comment that says getters and setters. So let's put that there. Now this is kind of training wheels, but it really helps you when you first get started kind of understand what's what, because you're going to want to remind yourself as you're going. And then the other thing that it does is just a part of learning this sequence of things. Now, if you're a really experienced programmer, do you add these little grouping comments? Well, you probably don't, but it doesn't hurt. Okay? All right. Let's go back and look at our instructions or recipe. We've added the getters and setters. We used the Eclipse wizard, so let's go to number 5. Add any constructors that you will need. Place them after the instance variables and before the getters and the setters. Okay, so we're going to insert these out of order. Now, sometimes we have to move them around to get them. Now, that may seem out of sequence, but traditionally, that's where Java programmers put them, after the instance variables and before the getters and the setters. Now, we can have two kinds of constructors. We can have a no argument constructor, which doesn't take any argument, right? And we can have a constructor with an argument that typically and now allows the client code to not only create a new object, a new counter, but to control the initial value of the instance variable. Now, I'm going to say that it's the nature of a counter that we don't want to start counting at a particular number, at least right now. So we want a no argument constructor. And you'll probably remember from the lecture that if the only constructor you're going to have is a no argument constructor, technically you don't have to have one. But we're going to say that this is a best practice. Because if you have constructors with arguments, you have to code explicitly the no argument constructor. So it's great. It's a great way to start. Okay, so how are we going to do this? Well, that was not what we were looking for at all. So let's see if we can get that back. There you go. There's your picture again. So let's shrink the proper thing. So now let's put in between the instance variables and the getters and setters, let's put constructors. We're only going to have one. We're going to have a no argument constructor. So it's public. Constructors are always public. They always have the same name as the class itself, counter. There are no arguments, so there's nothing to go in the parentheses. Okay? And there's no explicit code that we need for a no argument constructor. So I typically just put a one-line comment in which I say no argument constructor. Okay? And that's going to take care of that. All right. Now, you might say to me, Kevin, when you construct a new counter, you're going to want to make sure that the value is equal to 0. Well, it just so happens that the default behavior for instance variables that are ints is that they're initialized to 0. So because we know that we don't have to really do any work in the no argument constructor at all. Okay, great. Let's keep going on. Let's find our recipe again. Now we're up to number 6. We want to add a toString. Okay, what does a toString do? Well, it provides a string-based representation of the state of our object. Okay, so our object keeps its state in its instance variables, and we have one value. It's not in a string format right now, so we're going to need to generate a toString. Now, it just so happens that we can do that with Eclipse, so let's go do that. So we're going to right-click anywhere in the editor, say Source, Generate toString. Okay, and it automatically says it's going to include the fields. We don't need to include any of the method stuff. That's kind of a fancy option that we're not going to get there. The insertion point is going to be after get value. That's down at the bottom. That's just where I want it. And so I'm just going to say OK. And there we are. We have the toString. So the toString is the first of the methods we have here that's not a getter or the setter. So I like to come up with a comment here where I just say other methods. Okay? Because it's not a getter or a setter, so I need a title to go over top of it, some kind of heading. Okay, so let's look at this generated code. All right? The generated code here is going to return what's in the instance variable value. Now, you may remember from the lecture that I said that it's really impolite to touch the instance variables directly except in the getter and the setter. So when I teach people to code a toString by hand, I always have them use the getter. I always have them use get value here rather than the name of the instance variable. Now, that's not what the Eclipse people do. And so we're left with the dilemma, do we change the generated code in order to be sort of more formal, more correct, or do we leave it there because we don't want to fiddle with generated code? And I'm going to go with the latter decision. We're going to leave it there. It's generated code. It may not be to my taste, but I'm going to leave it there, and I'm going to always, to the extent that I'm going to generate a toString automatically, I'm just going to leave the code there that was automatically generated. Okay? So that's going to take care of that. All right. So let's look at the recipe again. We want to note that this is an override. Okay, let's note that. Okay, so the toString is a method that our class, a counter, has inherited from the mother of all classes, the object class that's in the java.lang package, the so-called java.lang.object. And it has a toString. It doesn't really do anything that useful, but at least if you call it, it will return some characters. So this is the first time we see one of these annotations, and this annotation is saying that this is an override. Okay, and I just wanted to point that out. Okay, this overrides the version of toString that is in java.lang.object. All right, we got that. Let's look again at our recipe. Okay, create a testing client class and test the code that you have created so far. Oh, great. And we're getting down towards the end too. Let's do that. Okay. Now, I mentioned in the beginning our client class is going to be called CounterClient. Okay. let's do that. So let's go into our Package Explorer panel, highlight the name of the package that we're in, right click and say we want a new class. Okay, and it's going to be called CounterClient. And this one is going to have a main because it's a testing harness for the counter class. So anything that we want to execute, anything that we want to run, has to have its own main. So the class that we're going to run is going to be CounterClient, and it is going to exercise counter. And we can leave the box checked for inherited abstract methods. That's just fine. So let's click on Finish. And here's our class. So now we're going to start to explore testing in a little more of a deliberate way than we have before. You know, before we typically have done our testing in the same class where we have our code, because we weren't using object-oriented classes as really convenient containers for our code. Well, now we're going to have a test class to go with each of our production classes. So counter is a production class. We're going to use it in our production code. And CounterClient is a test class. So let's go about the testing in a little more deliberate way. So what I want to do is I want to test everything that I've put into counter. Well, let's look what's there so far. We want to be using the instance variables. So if we use the methods, that's going to work. We do have a constructor. We have a no argument constructor, so we're going to want to explicitly test that. We want to make sure that we're able to create a new instance of counter. We're going to want to test the getters and the setters, okay? Now, getters and setters really fall into a category which we almost call too small to fail. We do want to test them because the getters and the setters are used in some of the other methods. We're going to rely on tests for other methods to test the getters and the setters. So we're not going to do those explicitly. And then we have the toString, and we're going to do that. We're going to test that explicitly. So right now, it looks like we're going to have a test for the no argument constructor and for the toString. Okay, let's see that happen. So I'm going to go back to CounterClient. Okay, and what I like to do in these kinds of test client classes is put a one-line comment to say what I'm testing. So I'm going to say test no argument constructor. Okay, so how do I do that? Well, I have to declare counter. I need a variable to hold a reference to a counter. So I use the class name counter. C1, not CV1, but C1 equals, and then we use the constructor. This is the first time in at least these demos that we see what the constructor is here. We're really not using the name of the class over here. We're calling a constructor, new counter paren. So we're calling the constructor that takes no arguments, has the same name as the class. Okay, so we're testing the new argument constructor here for sure. Okay, and then what could we do? Well, in this kind of a test scenario, the only thing we can do is to print things. Well, the easiest thing we can do is to print things and then to go inspect them. So here's what we're going to do. We're going to say sysout C1, okay? And so what's going to happen there, we're going to expect value equal to 0. So when you're doing these kind of manual tests, people like to put the comments on the print statements where we can see what value is expected, okay? And then you're going to have to go and look, okay? Let's close that console. That was from something else. Okay, so what happens when we print and we use as an argument the name of the variable that points to the new object? Well, it turns out that it calls the toString, okay? The toString is responsible for creating a string representation of that object. So we call the toString. And the toString should be telling us that the counter is equal to 0. Let's just see. Yeah, counter. So we have a counter class. We have an instance of the counter class where value is equal to 0. That's exactly what we have. Now, I'm going to say that we also want to test the toString. I know we've implicitly tested the toString here, but the next kind of testing that we do, we're going to test the toString explicitly, independent of any of the constructors. So I just want to have us having a separate test for each of the constructors and a test for the toString. Even though in this code, this is kind of redundant. So we're going to say test toString. All right. So we're going to declare another counter. And can we use C1 again? No, we can't because it's already been used. So I'm just going to call it C2 equals new counter. All right. And now I'm going to sys out that C2. And again, I'm going to expect it to be equal to 0. Expect value equal 0. So let's save it and run it. And not too surprisingly, it's essentially the same code that we had above. We get the same result. Okay, so we've tested the no argument constructor and the toString. Do we have anything else to test right now? And I'm going to say the only other things would be the getter and the setter for value, and we're going to test them implicitly in a couple of minutes, so I'm going to hold off on that. Okay, so now we're ready to create more code. All right, so what I usually do, and if you look at my recipe that I recommended to you, is I go down to the toString. Once I get that going, I can start my test code. And then once I get tested down through the toString, then I want to add more code. It's always good to add a little code, test a little code. So when you go to add more code, you can go add the test for it and test it right away, even if you're not finishing up all of the production code. So let's take a peek at our next part of the recipe. We've already done 7. Okay, so let's do 8. If you need to implement an equals method, then use Eclipse to generate both hashcode and equals methods. After doing so, test the equals method. Well, let's do that. So you'll remember that we need an equals method because we can't compare instances of objects to each other's with the equal operator, because that will answer the question, are these the same instance? And we typically don't care that. What we want to know is, are these instances that contain the same value? Okay? So, how can we do this? Well, it turns out we want to generate that code as well. So let's just go look. Right click in the editor, source, generate hash code in equals. Well, that's more than we're thinking we need. Well, it turns out that hash code is a method we're going to learn about later, several chapters later, and it needs to be coordinated with equals. They need to have parallel behavior, okay? So it always works out well to generate them and to generate them at the same time, and that's why the wizard in Eclipse generates them both. So we have a list of instance variables. In this case, we only have value, and it's by default it comes checked. And here's the question that we're trying to ask. Of all the instance variables that this object has, which ones do we want to consider in order to see if we want to consider them equal? Well, this is very important. So here we only have one, so we're going to need at least one. So the default value is just fine. So let's click OK. And here we got the override and the equals. Okay. So we're expecting these to work if we're only considering the value of the value field. I know that's a little redundant, but I hope you know what I mean. Now, we're only going to test equals at this point. And because these two are generated together, I usually feel pretty confident that if I test the equals and it works out well, then I don't have to test the hash code explicitly. All right? So, all right, that's our code. Let's save it. Let's go back to CounterClient, and let's code a test for equals. I see I misspelled value back there. Let's get that fixed. Okay, so we're just going to say test equals. Okay. So let's see how this works. So we want to create two counters. Okay. So let's create counter C3. That's the next one to create. Equals new counter. Okay. And let's create another one, counter C4. And construct that, call the no argument constructor new counter. Okay. Now, we want to, if we really want to be thorough, we want to demonstrate to ourselves here that these two are not the same object. Okay? Well, that would mean if we did an equal test between C3 and C4, we should get false. Okay, let's see if that works. So let's say sysout, and then let's just put the expression C3 equal C4. Okay, and I'm going to say expect false. And let's save and run. And we got a false. Okay. Now, what's going to make these two true? Well, if we call the equals method instead of using the equals operator. Okay, so let's say sysout. Now we're going to say c3 dot equals, and then in parens c4. Now we're expecting this to be true. Expect true. Now let's see what we get. We're going to save and we're going to run. It's true. Very good. All right. Well, we're getting down towards the end of our recipe, but not all the way down. So let's look at our recipe. We have now finished 8. We have the hash code in the equals, and we tested equals. And because equals tested out, we're going to trust our hash code, which we're not going to be using for a while anyway. And then we're down to the last one. Add any additional methods, sometimes called worker methods, that are required. Place them at the bottom of the class after the equals. After doing so, test the new methods. Okay. Now, in the very beginning of this tutorial, I said we're going to have 2 worker methods. One's called increment, that increases the count by 1, and one's called decrement, that decreases the count by 1. So let's add just one of those and then test that. Okay, so let's add increment. So go back to counter. Okay, and sometimes what I'll do is I'll even put in a comment and call these worker methods. Of course, they are other methods that are not getters and setters, so I don't really have to have this here. Okay, now worker methods, okay, methods are going to be used to implement the functionality of the class. They typically are going to be public, okay, because we're going to want client code that uses this class to be able to call the methods. If not, it's not going to be very useful. So let's at this point say public void increment, that's the name of the method. So it's not going to return anything. It's going to be public, so any code that uses this can call it. All right, and then let's create some code. All right, that's good. Now, I'm going to show you a couple of versions of this, okay? The naive version of this doesn't use the getters and the setters, okay? So let's do the naive version, also called the impolite version. Well, in the impolite version, we just use the name of the instance variable value, okay? And what do? We just say value plus plus. Okay, that's fine. Okay, so let's go and do a test for the naive version of increment. Okay, that sounds good. So let's come down here. Say we want another test. So let's test increment. Okay, so we're going to need a counter. So let's say counter, now we're up to C5, equals new counter, call the no argument constructor. Okay. And then we're going to want to call increment. So when we construct the counter, the value should be 0. And then if we call increment, if we say C5 dot increment, double click there, we're going to expect it to be up to 1. So why don't we print C5 with a sysout, C5, okay, and why don't we say comment expect value equal 1. Let's see how that goes. So let's save and run. Value equals 1. Gosh, things are going well. All right, so what's wrong with the current version of increment that we have? Well, we need to refactor this a bit because we want the same functionality, but we don't want to have touched an instance variable directly in a method that was not a getter or a setter. So how could we do this? Well, here's what you do. Instead of value plus plus, we use the getter and the setter. So we want to set value equal to an expression which is get value paren plus 1. Okay? So we get the current value, add 1, and use that to set a new value. All right, so that's classier. And I'm going to take out these extra lines to just have it look really compact. All right, so that should have the same impact, but be a much more appropriate good practices version. So let's go back to CounterClient. We're still expecting a value of 1, so let's run it again. And now even the clean version gives us 1. And then we've got one more method that we need to do. And we want to do one called decrement. Okay. Now I'm going to show you a cheater trick. So I'm just going to go to increment. Okay. And when I copy it, of course, I have an error because I got two things of the same name. But instead of inc, I'm going to have decrement. Okay. Now I'm going to make a mistake here. Okay. I haven't changed the code. A lot of times when you're copying, when you're cloning code, you'll remember to change the name of the method, but not the logic. See, so I've got wrong logic here. This should be a minus, and I've left a plus. So let's go back. Let's save that. Let's go back, create a test for decrement, and let's see if we can catch that error. Okay, so comment test decrement. Okay. So let's create another counter, call it C6, and call the no argument constructor. Okay. Does that work all right? And so now we should have one that's at 0. And here's what I'd like to do. I could increment it by 1 and get it to 1, and then decrement it by 1 and get back to 0, and then I could expect 0. But I don't think that demonstrates it in a really different way. So here's what I'd like to do. I'd like to increment it 3 times. So I'd like to say C6 increment. Okay, so that's 1. I'm going to copy that twice. 2, 3, that should get it to 3. And then I want to say C6 decrement. Okay, and now I'm expecting that to get it back down to 2. Okay, and so now I'm going to print it, sysout, C6, and I'm going to expect value equals 2. And let's look at that. All right, let's give it a run. Now, remember, we've got some bad code there, so we're expecting this one to fail. Whoa, value equal 4. Now what did we do wrong? We go back and look at decrement. Oh, we changed the name of the method when we cloned it, but we didn't change the sign of the operation that we're doing. So we didn't actually subtract. So let's fix that code and let's go back to CounterClient and let's run our test again. Value equals 2. So that's pretty well it. Now we've got counter and CounterClient, and let's just go back and look at our recipe. Our very last thing said add any additional methods, the worker methods, that are required. Well, we had added increment and decrement. Put them at the bottom of the class after the equals, and after doing so, test the new methods. Well, we've got it all done. End of recipe. So we at this point have done it all. Okay, we have both the production class, counter, and the test class, CounterClient, and we're running the test and we're getting all the expected values, which is just what we need. And given our current set of methods, that's all we can do. So feel good about this. And I'm going to say bye until next time. Bye-bye.